So we've been very deliberate about trying to make this a truly global conference and a global event. And we really are, we're focused on that. And even when it comes to, programming, we've, programming chairs are also all focus area leads are from all over the world. And we found them highly engaged, and they're very excited about the program, and they're contributing, and they've really spread the word. And so we're hearing from all over the world about how people are looking forward to it.
That's probably one of the biggest strengths of the IMPC organization, is that it does truly bring together the international mineral processing community. And you're going to see a lot of different perspectives on mineral processing coming out of that from different regions of the world. And that's very exciting, getting a chance to see and hear those different perspectives. And it often makes you think a little bit differently about something that you've been working on or focusing on, trying to find a better way of doing something. Getting that additional perspective that's coming at it from a very different background is really helpful.
I will add to that, John. I think, as you mentioned, bringing together the global community in this way, you do see different groups and organizations working on problems that are maybe more pressing in their area of the world, and it's a great opportunity for others to learn and to think differently and to maybe think about future opportunities in that space that maybe yet hasn't been at the forefront of their mind. So I think a really good opportunity to learn from that diverse perspective.
Typically at these conferences, it's all about networking. So because we're attracting a large industry base, given SME's expertise in pulling together industry at these meetings and the traditional exhibit at the SME annual meeting, we're expecting a lot of industry to come in, as well as a lot of academia that the IMPC is known for. We want the IMPC 2024 to be a place where academics and industry can really connect meaningfully. As John and Ronel mentioned, there's a real dearth of mineral processing engineers these days, and it's a good time to be a mineral processing engineer. There's a lot of poster sessions, and we expect a lot of students to be participating in posters, so they get a chance to talk individually one-on-one with prospective employers about their research and their work, and trying to find opportunities for themselves.
The other thing, maybe just to build on that a little bit, Tarun, is there has not been an IMPC, proper IMPC conference for 6 years. Because of the pandemic, there's been quite a pent-up demand for a conference of this nature. And we think that presents a great forum for the entire mineral processing community, including students, but academia, industry, and suppliers alike. It's a great opportunity for everyone to get together and exchange ideas. We're on the front end of the energy transition, and it's a massive change globally in how energy is produced and used. The next generation is going to see massive changes in the way energy is produced, the way it's transmitted, the way it's stored, and of course in the way it's used in transportation and everywhere. The only way for this energy transition to occur is through metals and minerals. So the energy transition presents a real challenge for the mineral processing community, because we've got to meet those needs of the energy transition going forward. So it's a very exciting time to be a mineral processing engineer and to be involved in the industry. Extremely exciting, but also challenges to be overcome. And often when you put those two together, it creates a really vibrant community, and we have that in front of us today.
In order to increase production of these metals, we're starting to have newer mines, and so newer greenfield operations have to come in, which is what we're seeing is that there's a significant decline in project NPV, and this is coming, some of it from the higher interest rate environment, but we're sort of seeing we're reaching this upper limit for what we can achieve through scale. So bigger isn't better, right? You got to fork out more money, and it's just getting expensive. So we really need improvements in productivity and novel technologies that can help us reduce energy, water, and mainly OpEx. How do you reduce capital costs? How do you reduce OpEx? And that's going to come with newer and more improved technologies. So we're talking about novel technologies, how to reduce our overall footprint, how to reduce, environmental footprint, how to, increase water recycle, how to use newer, more efficient, for example, flotation cells.
Yeah, I'll add on to that, Tarun. To me, what's really exciting is that we're really shifting focus on some of the minerals that we will need to be processing in the future. And in addition to that, some of the products that we're producing that we'll have to recycle, where we again can apply mineral processing in very innovative ways. Some of the abstracts submitted for IMPC 2024 relate to how we can recover some of the materials in use in batteries. So for example, some of the graphite material or some of the lithium, nickel, things like that. So how can we reuse when the batteries are at their end of life? How can we reuse and recycle that material?
Yeah, and to build on that, lithium is a great example of a commodity that is being changing dramatically. It's been used in most battery materials that are used for transportation now, and recycling of lithium is critical. And there are many ways being looked at to recycle that lithium. But also the other metals in these battery materials, nickel, cobalt, manganese, and all of these metals, can be actually recovered from spent battery materials. And the lithium business is pretty interesting because it's grown from a very small, I would call it a niche mineral with fairly limited uses. It's grown overnight to where it's a pretty major commodity, and the demand far outstrips what the industry can currently supply. And so mineral processing is being developed right now for recovery of lithium from a whole variety of different sources.
In addition, there's other sources of metals that we're now hearing about. People are talking about recycling printed circuit boards and several other ready-made consumer electronic items. And we're seeing that mineral processing techniques are now being applied to these separations as well, which is so it's an expansion of the field, and we're seeing new knowledge being developed every day.
It's really critical that we improve those relationships. It's important for academia to understand the types of problems and the context of the problems that industry is trying to address, just as it is important for industry to understand what opportunities academia have been exploring that could offer potential solutions. And IMPC 2024 will be a great opportunity for both industry and academia to get together and strengthen those relationships and learn more about the context in each other's functional areas.
The other piece of that is just that academia is the front end of human resources for the mining industry. So the technical expertise has to come out of academia, and the health of these academic programs around the world is vital to ensure that supply of expertise into the industry. And IMPC is an international conference that does pull academia in, but also provides exposure to the industry and all the links that Ronel and Tarun have talked about as well. So it's critical that we foster this relationship between academia and industry and enhance it. And the other piece of that is research and development. Research and development starts within academia. It doesn't end there, but it starts there. And so having those strong relationships is critical.
Academia has been the bedrock of innovation and productivity across several industries, and mining is is no different. The research must, advance both basic and applied sciences. And with regards to the latter, it must strive to be relevant to industry problems. And, the academic community must push to do bolder research, even if it does not lead to favorable outcomes. But to do so, they must receive industry funding, which has not necessarily been the case in the United States. So industry must, open up to academia, to bring to them the toughest problems and fund this work, reducing relying on other sources of funding, which is the case, so they can do some quality research.
IMPC does take a lot of pride in recognizing and providing industry recognition, and the IMPC gives a Lifetime Achievement Award. It's always fun and interesting to recognize that person who's always a significant figurehead in the mineral processing community. But also IMPC does give out young author awards to outstanding papers by authors under 35 years of age. Very, very pleased to do that. It's great recognition for younger members of the mineral processing community that are making the effort to publish and share their ideas. And of course, that's what we want to foster in the industry. That sharing of ideas is critical because it gives that author a peer review. They're getting others outside of their immediate community wherever they work, whether it's academia or industry. They're getting that peer review, and they are growing and developing. And there is a lot of that happens in the academic world. More of that needs to happen in the industrial communities. People need to be publishing more. Young engineers in our industry need to be publishing papers, not just for the sake of publishing papers. It's for their personal development and to ensure that they are developing in a way that is going to be most beneficial to their employers and the community at large.
A lot of the wonderful sort of innovations that we see today in the mineral processing industry, be it new grinding rolls or grinding equipment or new flotation cells or improved tailing options, all of them have been a result of collaborations between the mining companies, the vendors, and academia. In many cases, these consortiums or these collaborations have taken the shape of research consortia with governments also supporting these. And so in some cases, we've seen vendors have had to work hand in hand with their competitors for the benefit of the industry, with material gains achieved, for all parties. It's going to be even more important as we try to usher mining into sort of the digital age with Industry 4.0 initiatives. A priority at most mining companies, equipment suppliers have had to work hand in hand with let's say chemical vendors or digital, traditional companies that do a lot of digital type of work to squeeze the next bit of performance from existing mineral processing plants.
There's many common and also problems of a significant scale that our industry has to face, and it makes absolute sense to leverage those collaborations and work together to address some of those challenges. One of my favorite quotes is from Helen Keller. It says, "Alone we can do so little, together we can do so much." And I really believe with collaborative research, we can achieve so much more working together. And so really looking forward to IMPC 2024 and more opportunities for everybody to connect and maybe establish that next collaborative research opportunity.
Water resources in the places where mining and mineral processing is done are becoming increasingly stressed. We see that particularly in North and Western United States, in Canada, in South America, and in Australasia. The water resources are stretched, and it's becoming critical to find new ways, new methods of conserving water and making sure that those, scarce resources are used appropriately. And so most companies involved in mineral processing around the world at least pay varying attention to water, but from substantial to extreme. So water is becoming increasingly important in our industry.
When you think about water, it's another one of our resources, and as we go forward, there's much pressure on our industry to reuse or limit the use of water, and that obviously affects water quality, and therefore we may have to make separations with the quality of the water different and challenging, causing some challenges. So it's a great technical problem that the industry has been dealing with in lots of different ways, particularly around seawater processing, for example. And we're going to see more of those kinds of challenges in the future, as there's, again, that renewed focus on limiting our use of water.
There is a depletion of groundwater and available water for all these for mining operations, especially if you talk about greenfield operations. A lot of the work that they're doing initially has now become about finding sufficient water. And in terms of permitting, even water is turning out to be one of the big issues. Before it was the space and the waste or managing the tailings. Now it's about where you're going to get the water. And so from that perspective, there's really a need to improve water efficiency. So use lesser and lesser water, recycle water, and or use other sources of water that are non-traditional sources of water. So now, so we're seeing people interested in trying to use seawater, and that's certainly the case in South America, where they are looking at the use of seawater for the processing plants. What happens to your processing efficiency and performance when you're using let's say seawater, brackish water, or hypersaline water, and all these and water that's minimally treated, or so these guys. So diversifying our water sources is the imperative, and at all these mining companies, and we're seeing that there has to be that things have to change.
And of course, the ultimate way to address the water issue is to go to dry processing. And we have a number of papers on dry processing. There's tremendous amount of interest around the globe in looking at options, ore sorting, and other dry separation techniques. Some of them at quite an early stage, but some of these technologies are really looking quite exciting for dry processing alternatives. And then, of course, tailings disposal. We are looking very carefully, the industry is, at methods for reducing water loss and water consumption in tailings disposal facilities through paste tailings and potentially filtered tailings in some applications, which in itself is a very challenging technology to be applying.
Every industry is looking to get more efficient, and energy is starting to get more and more expensive. And this is where, and also the idea around scale. When you're scaling these new operations, it's not necessary that bigger is better anymore. And because energy costs are not scaling really well enough. So it is imperative for all new greenfield operations to try to find a way to become more efficient, more energy efficient. That is possible these days with many improvements that we're seeing, especially in comminution. So in size reduction, we're seeing seeing improvements in new technologies for comminution or size reduction that allow gains in efficiency. And this is if you think about it, comminution and size reduction is the greatest expense for any mineral processing operation. And so any even minor gains in efficiency that you can squeeze out of this result in significant savings. And so all mining companies are very focused on trying to find ways to become more energy efficient.
And the other aspect of this is all major mining companies, certainly in the Western world, are having to produce sustainability reports and are reporting greenhouse gas emissions, water consumption, and are really closely looking at Scope 1 and Scope 2 emissions, and working very hard to reduce CO2 emissions. But regardless of that, as Tarun and Ronel have said, energy efficiency translates into cost efficiency, and so the emphasis is on being competitive, remaining competitive, and enhancing your competitive position in the overall minerals industry environment. So, energy efficiency is a really core piece of that aspect.
We do have a wonderful innovation and research and development sessions planned, and one of these sessions is focused on processing in extreme environments, whether that's space or whether that's deep sea mining and processing.
There's a lot of overlap in between the learnings that we can achieve from mining in extreme environments, as well as with what we want to do currently on Earth, which is improve our energy efficiency, improve our water efficiency, all of those things. I think there's a lot of overlap, and I think the learnings will translate, and I certainly think these efforts are worth it.
When the research and development community, whether it's academia or industry or collaborations, works towards a particular goal together, it's sometimes the things that you learn that aren't directly related to that end goal that actually bring you the biggest benefit. And you don't know that when you go into it. You don't know what you don't know. Sometimes you don't know what you don't know and it's bad. Sometimes you don't know what you don't know and it's very good. So it's creating those opportunities for creating something that is a development that pushes you in a new direction. And I think Tarun's exactly right. It's like the moon landing. So many great developments came out of landing somebody on the moon, other than just landing someone on the moon. And those developments are what moves technology and what moves an industry forward. And I think we have an opportunity right now, particularly with this energy transition, to realize a lot of those benefits. A great one that just to give you an example, energy storage for the energy transition. Energy storage is really important, because we're often, we've got opportunities to generate energy, but not when it's needed. And so being able to store that energy and being able to use it at the right time is critical.